In the previous lecture, we talked about exact differential equation and also linear differential equation. We now have Bernoulli equation. For Bernoulli equation, we say if we have, look, up to here, I mean, this part of the equation is the same as linear differential equation. But here we have q of x, which is multiplied. This was q of x in linear. But here we have a function of x which is multiplied by y to the power n. And the power must not be 0 and 1. Okay, if it's 0, so it's linear. If it's 1, we can't solve by this method. So now, if n is not equal to 0 and 1, this is called Bernoulli equation. This is called Bernoulli equation. As you see here, we have dy by dx plus bx times y. Here, bx is a function of x times y equals cx times y to the power n. The power of n is not 0 and not 1. Okay, it's neither 0 nor 1. If the equation is on this form, what we do a substitution. We use this substitution. We say we let z to be y to the power 1 minus n. If it's linear, if it's Bernoulli equation, we first do this substitution. We use this substitution. We say z equals y to the power 1 minus n. N here is the power of y there. Okay, that's n. So we say first we divide both sides of this equation by y to the power n to get only a function of x in the right hand side. We must have only a function of x in the right hand side. We must have no y in the right hand side. So if we have y to the power n, we divide both sides of the equation by y to the power n to get a function of x in the right hand side. After dividing both sides by y to the power n, what we get? We get y to the power n minus n times dy by dx plus b of x, y to the power 1 minus n. Look, if we divide this, it's y, it's b of x, y to the dividing by y to the power n. When we move this to up, it becomes b of x, y times y to the power minus n, and equals b of x times y to the power 1 minus n. We just add the exponents. Okay, so we get y to the power minus n dy by dx plus b of x times y to the power 1 minus n. In the right hand side, we just get c of x, because in the right hand side we have c of x times y to the power n. If we divide by y to the power n, we just get c of x in the right hand side. And now we use the substitution. We have z equals y to the power. We have z equals y to the power 1 minus n. We are going to find the derivative of both sides with respect to x. Both z and y are functions of x. So finding the differentiation, we get z becomes dz by dx. And y to the power 1 minus n, it equals, we're going to bring the power to front, 1 minus n. Then we reduce the power by 1. We get y to the 1 minus n minus 1. These two are cancelled, so we just get y to the power minus n. Okay, times dy by dx. Since y is a function of x, we use implicit differentiation. ده شيء خب خب كاري. هذا شيء اللي كله. صدق جميل كشمان. ليه ده شيء خب خب كاريين. كذا ده شيء y ورجلين. أبي أصدر بيشيب كم y prime. Y prime is dy by dx. And here we divide both sides by this coefficient. We divide both sides by this coefficient. Only the coefficient, only the number. Okay, and we get 1 over 1 minus n dz by dx equals 1 equals y to the power minus n dy by dx. As you see here, we got y to the power n minus n dy by dx. We got this term. And we replace that term by this one. And then we replace y to the power 1 minus n by z. And in the right-hand side, we have c of x. We just do these substitutions. And then the differential equation becomes a linear differential equation. It becomes linear differential equation. Here, we have dz by dx times 1 over 1 minus n. And in the linear differential equation, we said the coefficient of the derivative must be 1. So we multiply both sides by 1 minus n here. We get dz by dx, 1 minus n times p of x, z equals 1 minus n c of x. This is q of x. This is p of x. It's linear. It's linear differential equation. So now we follow the steps that we did in linear differential equation. We are going to find the integrating factor, and then we say we just follow the steps of linear differential equation. After using the substitution, we must get a linear differential equation. Look at this example. In this example, it will be much easier to understand. Here we have dy by dx plus 1/3 y equals e to the power x, y to the power 4. First, we must know what's n. What's n here? N is the power of y in the right-hand side. What's the power of y? Is 4. As you see, the power is 4. That means n is 4. So we say n is 4. This is n. And now we are going to divide both sides of this equation by y to the power 4. As we said here, in the first step, what we do, we divide both sides of the equation by y to the power n. After dividing by y to the power n, we get this form of the equation. This is a form of the equation after division. After dividing by y to the power minus y to the power n. And we get this equation. We do the substitution here for this equation. Let's first divide both sides of the equation by y to the power 4. If we, let's say it's equation 1, we say divide equation 1 by y to the power 4. وثمان أبتن ها إك النخشة بينتو إكس تابع للراس. واتواي بتواني هرشان يبو هردو لدابة شي واقي. لير هردو لدابة شي واي بتواني شواركين بويكتن ها النخشة إكس ما بمينتو. If we divide both sides of the equation by y to the power 4, what we get? We get y to the power minus 4 dy by dx plus 1/3 y times y to the power minus 4. كاتي دابا شنو كاتي y لسر y توين شوار يبين وسر y توين ناقص شوار. Okay, equals e to the power x dividing by y to the power 4. These two will cancel out, and we have only e to the power x in the right hand side. And now we do the substitution. We use the substitution. We said we let z to be y to the power 1 minus n. We let z to be y to the power 1 minus n. This is it. Then we are going to find the derivative of both sides with respect to x. For the left hand side, we get dy by dz. Sorry, dz by dx, not dy by dz. We get dz by dx. As I said, we are going to find the derivative with respect to x for both sides. And this is the left hand side. And the right hand side, we get 1 minus n. What's n here? Let's write down n. N is 4. So this power becomes 3. Is it? Minus 3, sorry. Okay, we get minus 3. Here we say z equals y to the power 1 minus n. And n is 4. If you replace n by 4, we get z equals y to the power 1 minus 4 and equals y to negative 3. This is y. This is z. Z equals y to the power negative 3. Finding its derivative, it equals minus 3 y. Then we reduce the exponent by 1. ياكل توانا كما كنا أو ناقصة كيش كنا مثلا it's minus 4. Then multiplying by derivative of function of y, which is dy by dx. This is dz by dx. But here I said we must divide both sides by this number, only the number. We divide both sides by minus 3. What we get? We get minus 1/3 dz by dx equals y to the power 4 minus 4, sorry, dy by dx. We use this substitution, and we also replace each y to the power negative 3 by z. Let's return to the equation. Here we said z is y to the power negative 3 and minus 1/3 dz by dx equals y to the power minus 4 dy by dx. Let's do this substitution. In this equation, as I said, in the first step, we divide both sides by y to the power n. After dividing both sides by y to the power n, we got this equation. And here, let me simplify this more. This one, it's y times y to the power negative 4 is y to the power negative 3, is it? That's, we get that, because y times y to the power negative 4 is y to the power 1 minus 4, so y to the power 1, y to the power minus 3. Now, we replace each y to the power minus 3 by z. And also, we replace minus 1/3 dz by dx. I mean, we substitute this for y to the power negative 4 dy by dx. Here, we have y to the power negative 4 dy by dx. We replace this by minus 1/3 dz by dx. Let me clean this. So we get this. Then plus, here you have 1/3 y to the power minus 3. Y to the power minus 3. And we say y to the power minus 3 is z. We replace y to the power minus 3 by z. So you get 1/3 y to the power minus, sorry, what z. We substitute there. And in the right hand side, we have e to the power x. And now the coefficient of the derivative must be 1. It must be 1. In linear differential equation, this coefficient must be 1. How to get 1 there? Here, we should multiply both sides of the equality by minus 3. If we multiply both sides by minus 3, what we get? Multiplying both sides by minus 3. We are going to multiply each term by minus 3. This term becomes dz by dx. Here we get minus z. In the right hand side, we get minus 3e to the power x. That's all. And now this is a linear differential equation. And now we are going to follow the steps of linear differential equation, of solving a linear differential equation. Here we say first we should determine p of x and q of x. What's p of x and what's q of x? P of x is the coefficient of the z. And q of x is the right hand side. So here p of x equals -1. P of x is -1. And q of x is -3e to the power x. The coefficient of z is p of x with the sign. We check with the sign. And the right hand side is q of x. And then we're going to find the integrating factor, mu. Mu of x equals e to the power integration of p of x dx. This is mu. And then it equals e to the power integration of. Here, p of x is -1, which is -1 dx. And it equals e to the power minus x. This is mu of x. This is mu of x. And then we say z times mu of x equals the integration of mu of x times q of x dx. Plus, sorry, that's all. We don't need to add the constant. After taking the integration, then we add the constant. Here, we just replace the mu of x by its value, which is e to the power minus x. And also we replace q of x by its value, which is 3 times -3 e to the power x. And here we say z equals, sorry, z times e to the power minus x, this mu of x, equals the integration of, what's mu of x? Mu of x is e to the power minus x times -3 e to the power x dx. Okay? And so these two are cancelled out because both are the same and they are multiplied. They both have the same base and the same exponent with different sign. It becomes e to the power 0 and it's 1. We get it equals the integration of -3 dx, which equals -3x plus c. That means z e to the power minus x equals -3x plus c. To find z, we divide both sides by e to the power -x. Here we divide both sides by e to the power minus x. That means we divide both sides by m, mu. It becomes z equals -3x dividing by e to the power minus x plus c over e to the power minus x. Now we can move these exponential of -x to up. And we get z equals -3x e to the power x. When you move it to up, the exponent becomes positive. It's negative. Moving from denominator to numerator, the sign of the new exponent is going to be changed from negative to positive. Plus c e to the power x. This is set. But we must find the solution for y. And we say, here we said z equals y to the power -3. Z equals y to the power -3. That means here y to the power -3 equals to -3x ex plus c e to the power x. We just replace z by y to the power -3. Here we should find y. Okay, so I guess هذول هل جيرين يسا كارتك عم جيركية عم جيركية. Okay, so what we get? We get 1 over y cubed equals 1 over -3x ex plus c ex. Then, if we take the cubed root for both sides, if we take the cubed root for both sides, what we get? We get 1 over y equals the cubed root of 1 over -3x ex plus CEX. This all in the roots. That means y, 1 over y equals the cubed root 1 over minus 3x EX plus CEX. That's all. And you even can simplify it more. You can simplify it more by multiplying this to here and this to here, by moving these two, or by interchanging the place of these two, we get y equals 1 over the cubed root of 1 over minus 3 x EX plus CEX. This is the result, and this is the solution for the Bernoulli differential equation. This differential equation is Bernoulli. Here we have the exponent of 4 for y in the right hand side. We first divide both sides by y to the power 4, and then we use the substitution. The substitution is z equals y to the power 1 minus n. N here is 4, which is 1 minus 4, and we get y to the power minus 3. That means z equals y to the power minus 3. And from this, we should find dz by dx. That means we take the derivative for both sides with respect to x. And here y is a function of y of x. When we take its derivative, we must multiply it by its derivative. I mean, we use implicit differentiation. We get minus 3 y to the power minus 4 dy by dx. Now we divide both sides by this coefficient, and you get this. Here, we replace each y to the power 4 dy by dx by minus 1/3 dz by dx. And also, we replace each y to the power negative 3 by z. After doing this substitution, we get this equation. And this equation is a linear differential equation. In linear differential equation, what we do, we just follow the steps. First, we are going to find the integrating factor. After finding the integrating factor, we say the integrating factor is e to the power integration of p of x dx. And here p of x is negative 1. So you get e to the power minus x. Then we use this rule for finding the solution for z. Then we get the solution for z here. This solution for z, I must find the solution for y. What we do, we are gonna flip both sides, okay? Then we take the cubed root for both sides to get y. And then by interchanging the place of y and the cubed root, we get y equals this. This is the solution. This is the solution for that differential equation. We must find the solution for y, not for z. In the substitution, we eliminate y and we have z in it. So the solution will be for z. Then we use the substitution to get y. The substitution is z equals y to the power minus 3. So you replace z by y to the power minus 3, and then you get the solution for y. This is for Bernoulli differential equation. Okay, and here n is 3. Here n is 3. Look, even if اگر هاتوا الريكه دياريش نكتبه اگر الريكه دياري نكتبه ليه يكسر ثاني كامل يكسر ثاني كتشيا كبرنوليا ليه y 12 man. Okay, so this is Bernoulli differential equation. And now we have applications of first order differential equation in real life and in sciences and also in engineering. Here we have the Newton's law of cooling. The Newton's law of cooling. We say the Newton's law of cooling is given by this differential equation. D capital T by D little t equals minus K T times Ts. Here, K is a constant. K is a constant. it would be given or not. Okay. Ts is the constant temperature, and it's the temperature of surroundings of that the object. كاتبون منالم parça asnek le فرق در هندا le شونه كدان دا le جوره كدان دا بليجرمي جوره كا بيس بلابو اما ts بليجرمي جوره كا اوكي object كنا يدورو بري object كا اما ts okay temperature of surroundings. So the general solution is given by, let's solve this one. And generally, we are going to solve this one. It is separable differential equation. It is separable differential equation. You can say d capital T by d little t equals minus k capital T minus ts. Ts is a constant. We first, in separable differential equations, what we do first, we first multiply both sides by dt. And if we have dx, we multiply it by dx. But here we have dt in the denominator. So we multiply both sides by dt. And what we get? We get d capital T equals minus k capital T minus ts dt. In the left-hand side, we have capital T, and in the right-hand side, we have little t, dt, little dt. But here, we must divide both sides by this bracket to remove capital T with dt, with d little t, okay? With d small t, dt بشكلين أبيت capital T لقلا نبيت. شون؟ إما جاك يعني أنا capital T أبيت capital T لقل d capital T أبيت تنها capital T لقل بيت وروها d small t تنها T لقل بيت ts. Look, this one is variable capital T, and d capital T it's differentiation about t. Okay, and here how to remove this bracket here? We divide both sides by capital T minus ts, and what we get? We get d capital T dividing by capital T minus ts equals minus k dt. This is separable differential. You could separate them. Now we take the integrations. Taking the integration, the left hand side is, this is constant. It's the same as to say, let's say x minus, let's x minus 2, 1 over this dx. What's the integration of this function? It's ln of x minus 2. Okay, it's ln x minus 2. It's the same. Ts is a constant. And we take the integration with respect to d capital T. It's ln of capital T minus ts. Yes, it's the same as that example that I give. So here it equals ln of capital T minus ts equals minus k t plus c. We just add plus c with the constant of integration in one side of the equality. It's enough. Now, how to get t here? How to get t? So we must take that t out of the angle of length. How? We must take exponential for both sides. ليه شون او capital t بين ما دلنا او قوش لنا كا ابيت شيف كم inversely لنا كبينا بوي كبروات inversely لنشيا ايه. So we take e for both sides and we get these two are constants. We get capital T minus ts equals a to the power minus kt plus c. And then we say it equals t capital T equals e to the power minus kt times e to the power c Can I say that? Here we say e to the power, let's say a times e to the power b, it equals e to the power a plus b. By using this property, we can separate these two. Okay, we can say it equals e to the power minus kt times e to the power c. Let's say it's c1. Let's name it c1. And here we have e to the power c1 plus ts. And e to the power c1 is a constant. A to the power a constant is still a constant. We name it c. Yeah. Okay. Do you know how this integration equals to that? Okay. This integration is the same as to this one. If we have dx over x, what's the integration of this function? Ln of x. Okay. So what if we have dx over x minus 3? Let's see. It's the same. It equals ln of x minus 3. Is it? And here we have d capital T over capital T minus ts. It's integration. This equals to what? This is a constant. Let's say it is 5, it's 10, it's any number. Okay? We say it equals to ln of capital T minus ts. That results. So this integration equals to ln of capital T minus ts. For ts, we have no values now. It's generally we do it. Okay, we do generally, but we deal with ts as a constant. We let that's a constant. Okay. So here, say que o qual era brin semanda. Jumarega ts. Has jumarega question. So now I'm going to tell you how do we cancel out that ln. Look, ln and exponential are inverse to each other. We say ln of e to the power x, these two are cancelled and you get only x. Okay, and also e to the power ln x, these two are cancelled and you just get x. Okay, how to cancel out this ln? We must take e for both sides. Okay, we must take e for both sides. If we take e for this side and for the other side, and we get these two are cancelled out. And in the left hand side, we have only t minus ts, because this e with the ln are cancelled out, and you have only t minus ts in the left hand side. And in the right hand side, we have e to the power minus kt plus c1. Minus kt plus c1. Okay? And then we say e to the power a times e to the power b, it equals e to the power a plus b. That means if we have e to the power a plus b, we can say it equals e to the power a times e to the power b. And here you have e to the power minus kt plus c1. We can say it equals e to the power minus kt times e to the power c1. And you also, yeah, sorry, that's, sorry. No. We are gonna just do one more step. We have one more step here, and then we move ts to the other side, becomes plus ts. Here you have minus ts, it becomes plus ts, and so t equals e to the power minus kt. This is e to the power c1. E is a constant, and c1 is a constant. Constant to the power of constant is still a constant. Okay, so we say we let this is to be c times that. If this is c, we have e to the power minus kt times c, and you can say c equals that plus ts, where c equals e to the power c1. So this is the solution must be on this form. For cooling for cooling problems. Okay. Only the solution. Okay. Look, you don't need to know this. Even if you know, it's better. Okay, it's better to know. Okay, try to know it, but here the solution of examples must be on this form. Here we have an example, and we will solve after taking a break. Okay, let's take a break first for 10 minutes. In this example, it says, according to Newton's law of cooling, the rate of change of the temperature T satisfies this equation. We have given this differential equation. Here it says where Ts is the ambient temperature. That means ambient means around. Okay. K is the constant, is a constant, and T is time in minutes. When an object is placed in a room with temperature 10 Celsius degree, this is temperature of the room. That means it is Ts, it's surrounding temperature. Yeah, we are going to write down all the information. Here, the room temperature, it equals Ts, which is 10 Celsius degree. 10 Celsius degree. And then it says it was found that the temperature of the object drops from 90 Celsius degree to 30 Celsius degree in 30 minutes. That means from that time, which is placed the object into the room, to 30 minutes, the temperature of the object is dropped from 90 Celsius degree to 30 Celsius degree. That means at the beginning, time is 0. At the beginning, time is 0. And the temperature of the object is 90. So at time 0, T naught equals 90 Celsius degree. And also, after 30 minutes, the temperature of the object becomes 30 Celsius degree, as it is given from 90 to 30 in 30 minutes. That means at time 0, the temperature is 90, and at time 30, I mean after 30 minutes, the temperature of the object becomes 30 Celsius degree. It says determine the temperature of an object after 20 minutes. We should find temperature of the object after 20 minutes. If T is 20, what's capital T? What's the temperature of the object? So now we should find the general form, I mean the solution for capital T, and then in the solution, we just replace small t by 20. We will get the result. Yeah. First, we should find the solution for capital T. This is the equation. D capital T by dt, it says D capital T by dt by d little t equals K minus K times capital T minus Ts minus K times capital T minus Ts. Okay. And so here we just replace Ts by its value. For now, we only replace Ts by its value. And Ts is 10 Celsius degree. We get D capital T by D little t equals minus K capital T minus 10. That's all. And now we are trying to solve this differential equation. It's a separable differential equation. First, we multiply both sides by dt, and we get D capital T equals minus K capital T minus 10 dt. Okay. So now we must divide both sides by capital T minus 10. We divide both sides by capital T minus 10, and we get D capital T. So this is the question. you're going out, and it's 25 minutes that you're going out. That's why you had to return soon. Really? That was okay. It's 15 minutes. So we just started 3 minutes ago. So that's why. Okay. Here, this is the equation. This equation is given. And you have given the temperature of the room, which is temperature of surroundings, which is 10 Celsius degree. And we said before, TS is temperature of surroundings. Here, only TS is given. We just replace TS by its value. We just replace TS by its value, which is 10. Only this is given. And the equation is this one. We solve this equation where TS to be 10, as it's given here. TS is 10 Celsius degree. Now, this is a separable differential equation. We can separate the variables. We first multiply both sides by d little t, and we get d capital T equals minus k capital T minus 10 dt. Okay, and now we must write down capital T terms with d capital T, and little t terms with d little t, and we get d capital T dividing by capital T minus 10 equals minus k d little t. Now we take integration for both sides. The left hand side becomes ln capital T minus 10 equals minus k t plus c. Let's say c1, or let's say c. It's okay. It's a constant. You just name as you want. Okay. So now, how to get capital T? We must take E for both sides. It's the same as the above one. It's the same as the general form that we solved. Here, we take E for both sides. If you take E for the side and for the side also, what you get? For the left-hand side, these two are cancelled out, and we get only capital T minus 10. And in the right-hand side, we get e to the power minus k t plus c. Here we have e to the power kt plus c. It's the sum of two terms. We can say it equals e to the power a plus b is equal to e to the power a e to the power a times e to the power b. Okay, that means we're going to separate these two exponents, and it becomes t minus 10 equals e to the power minus kt times e to the power c. This is a constant. We name it a. Okay, we name it a. Let's say e to the power c to be a. E is a constant. To the power of constant, it's still a constant. We name it a. So we say we move this negative 10 to the right hand side, and we get capital T equals e to the power minus kt times a minus 10. Okay, so this is plus 10. When you move it to the right, it becomes plus. And we get t equals a e to the power minus kt plus 10. This is the solution. This is the solution for t. This is t of t. Which one? T capital, A capital. Liri alinchi e batwani bablin chwal. Constant niya. Nanam A. E batwani C. C constant. Each constant. E 2.5 approximately. Okay. E batwani C. Wada anyam yaksame ba A. Griman or yaksana ba A. Where e to the power c equals هبوس هذا كيف نسيان اي بتواني سي بوها بهالكون انسان نعلم ايوه اوكي yes. Yes, that's at any time. K is a constant. We will find it. We will find it just only. Okay. We'll find it by using the conditions. Here, you're not here when we talked about the conditions. We say we have an object. The temperature of a room is 10 Celsius degree, or TS. We place the object into that room, and the temperature of the object is dropped from 90 to 30. That means at the begin, temperature of the object is 90 Celsius degree, and it becomes 30 Celsius degree after 30 minutes. That means at the begin time is 0. At the begin, سرتاك جريمة مجهولة معها play قال ميكي دبلة تنك معها objective معها اللي يرداني play قال مجهولة كدبلة بالتأكيد لبري play قال مجهولة كم ترى play قال مي objective ده بسيط. okay نوت play كداني سرتاك كدانم time شيا صفر. So temperature of the object is 90 Celsius. This is temperature of the room, TS. Okay. So now we say after 30 minutes, that means if little t is 30, the temperature of the object is 30 Celsius. That means when time is 30, temperature of the object is 30 Celsius. I mean, capital T become 30. And at the begin, when little t is 0, capital T is 90. And so here, we use these conditions to find the value of C, of K and A also. That's a constant. It says K is a constant. Look here. K is a constant of proportionality. For example, okay. Here we say to find K and A, we say A is e to the power C. We apply the conditions onto this equation to get A and C. The first condition is when T is 0, then capital T is 90. That means T of 0 is 90. Okay, this equation which you got is T of T is A e to the power minus KT plus 10. This is the equation. And if little t is 0, capital T is 90. That means here we replace capital T by 90 and little t by 0. We get 90 equals A e to the power minus K times 0. We replace little t by 0. This little t we replace by 0 plus 10. And this equals to 1 because e to the power minus K times 0 is still 0. So you have e to the power 0. E to the power 0 is 1. And we get 90 equals A plus 10. And so A is 80. We move this to the other side, becomes negative. 90 minus 10 is 80. So this is 80. This is A. This is the value of A. So now we say capital T equals, we just return the value of A to here. Capital T equals AT e to the power minus KT plus 10. Okay, so the equation becomes this. This is the value of A. We found the value of A, so we return to the equation. And now we have another condition. The other condition is, it says if little t is 30, then capital T is 30 also. If little t is 30, so capital T is 30 as well. So now what we do, we say T of 30 equals 30. That means we replace both capital T, this is little t. This is capital T. We replace both by 30. As it's given here, it says after 30 minutes, the temperature of the object is 30 Celsius. So in this equation, we replace both T by 30. And let's see what we get. So 30 equals AT e to the power minus K times 30, which is minus 30K. Is it? So just set K, not T. Yeah. We get this. Plus 10. We now move this to here. We get 30 minus 10 is 20. 20 equals AT e to the power minus 30K. Then we divide both sides by AT. If we divide both sides by AT, we get 1/4. Is it? If we divide both sides by AT, we get 1/4 equals e to the power minus 30K. Is it? We just divide both sides by AT. 1/4 is 0.25. I'm going to write down 0.25 here. Now, to find K, K is the exponent of E. How to take it down? Yes, by taking ln, because ln and E are inverse to each other. So you take ln for both sides. You say ln 0.25 equals e to the power is ln e to the power minus 30K. These two are cancelled out, and here we get minus 30K equals ln 0.25. How to get K? By dividing both sides by 30, and we get K equals ln 0.25 dividing by minus 30. Let's find this value. Let's find it. Let's find ln of ln 30 and then dividing by minus 30. Here we say 30 this 30, its ln is this is ln. This is ln 30 as 3 points. So it's we must find ln 0.25. Sorry, we should find 0.25. It's ln. We should find the ln of 0.25, and let's see what's the result. The result is minus 1.386. 1.386. This minus. So K equals minus 1.386. Is it? Divide by 30 minus 30. Negative divided by negative is positive. So we just divide. We say we say 1.386 dividing by 30 is equal to 0.046. Let's say 0.05. It's approximately 0.05. So you say the result is K equals 0.05. It's approximately that value. Now we return this to the function. Yes. K is a constant. It's only a constant. No, it's nothing. It's only constant. Constant of proportionality. Here we say, what's the equation now? From this equation, if you replace k by its value, what we get? Let's see. We say t equals, let me write down below. So t equals at e to the power minus 0.05 t plus 10. This is equation. This is the equation after applying the conditions, after finding the values of k and a. And here, you should first apply the condition at time 0, then apply the other condition, as we did now. Here, we first apply the condition for t little t to be 0, and then we apply the second one. Okay? This is the equation. And now, in this equation, if you replace t by any time, we get the temperature of the object. Let's here, we have given t to be 20. What's temperature of the object? That means t of 20 equals at e to the power minus 0.05 times 20 plus 10. We just find this, okay? 0.05 times 2 times 20 is 0.1. That is 0.1. Okay? So it's 1. It's 1. This is minus 1. Okay? So the exponent becomes minus 1. And here we get t of 20 equals at e to the power minus 1 plus 10. Now we are going to find e to the power minus 1, then multiplying by 80, then plus 10. Then we will get the result. Let's find it. We say e to the power minus 1. So we just take minus 1 minus 1. Sorry. Minus 1 e to the power minus 1. Then it's exponential. What's e? That's e. That's e. Then we divide 1 by this. We get e to the power minus 1. Let's see. 1 dividing by e. We get 0.3678. Or 1 dividing by e. Since here we have e to the power minus 1. We have e to the power minus 1. It means we have 1 over e. 1 over e is 0.3678. 3678. So you get, we have 80 times 0.3678 plus 10. Now let's find this. We multiply it by 80, then plus 10. Multiplying it by 80, we get 29.4. That's 29.4 plus 10 is 39.4. That means it equals 39.4. Let's approximate this. We should write down in approximate. It is 39. Okay, so the temperature of the object after 20 minutes is 39. After 20 minutes, the temperature is 39 Celsius degree. That means T of 20 is 39 Celsius degree. This is the required. ليه أو object كمان نوجه لك هذا منا على كذا كسرت داين no play. دو 30 دقيقة play جرمتي بس. أي دو 20 دقيقة play جرمتي بس أنا دو سيمانة بس أنا سينو play. بس 39 Celsius degree. So here you have some exercise that's for yourselves. Now you have natural growth and decay. We have natural growth and decay and 2 more applications that's for next week. Okay.